Okay, so this is for distant learning to try to help y'all out with calorimetry. I know working math problems on your own is really hard, especially whenever you don't have a teacher in front of you explaining it. So this is my best shot at being in front of you and explaining it to you. So before this is day 3, or the third assignment, and it's calorimetry, and it's the first set. And there's all these questions, fill in the blank, and then the lady works a problem with you. Then she gives you a second one to try on your own, and she gives the answers at the very end. And then there's one that I put on there that is still involving the same things. You just now have to work it. So I'm going to read it out loud. It's problem number 6. It says a pre-1982 penny weighing 3.14 grams is heated to 100 degrees Celsius in boiling water. It is immediately dried and placed in a styrofoam cup containing 10 milliliters of water at 25 degrees Celsius. What will be the final temperature of the water in the penny? So a couple concepts we have to go over first. They're sticking it in a styrofoam cup. They're doing coffee cup calorimetry. So you're looking at that heat exchange. And we know that heat cannot be created or destroyed. It can only be transferred. And so all of the heat from the penny, because the penny is hotter, it has a higher temperature than the water. 100 degrees is hotter than 25. That penny is going to transfer heat into the water until it reaches a certain degree, and they're going to have the same final temperature. Because that heat transfer, once they both have the same heat, they're not going to transfer anymore. It's like if I put, I don't know, something that's room temperature, like my whiteboard that's in my lap that I'm about to use, and I put it on the table, they're both going to stay room temperature. They're not going to exchange heat because they're the same heat. If I put if I took something out of the microwave or off the stove and I put it onto my table, it's going to make my table hotter. It's going to transfer that heat until they're the same temperature, and then they're going to stop. So heat transfer. So the final temperature is going to be the same. So you're only actually solving for one variable. The other thing that we need to talk about is the boiling water. Don't let that confuse you. They put the penny in boiling water to make sure that that penny is the exact temperature that they want, because metal is a hard thing to heat up exactly. It transfers heat. And so if they stick it in boiling water and all of the water is 100 degrees Celsius, then the heat transfers the same to the penny, and it's consistent, and it's just a method in science. So that water we're not concerned about. The boiling water we're not concerned about. We just know that that makes our penny 100 degrees Celsius. The water we're concerned about is the water that's it's being placed into in the styrofoam cup. The other thing, 10 milliliters. Water has a density of 1 gram per milliliter. So if I know how many milliliters I have of water, I have that many grams. So if I have 25 milliliters of water, I have 25 grams of water. So you can go pull out your water bottles and look how many milliliters it says, and it's that many grams. That's how much it is, because that's the density of water. So all that stuff, let's go back and rewind and think about the problem again. So I'm going to show what I've written down for variables as I work through the problem. And so it says a pre-1982 penny is weighing 3.14 grams. So I put M for mass, and then I put a P for penny. It's 3.14 grams. And then it says it's heated to 100 degrees Celsius. So I know TI, initial temperature of my penny, is 100 degrees Celsius. It is immediately dried and placed in a styrofoam cup containing 10 milliliters of water, aka, because that density thing, 10 grams of water. So M for mass of water is 10 grams. Of water at 25 degrees Celsius. So TI for water, initial temperature for water, is going to be 25 degrees Celsius. It says, what will be the final temperature of the penny in the water? So TF is the same for both of them. So I just have one TF. And then if you go back to problem number 4 that she works with you in the video, she also uses a penny and she also uses water, and she gives you the specific heat. So the specific heat of water, which I should have put a W there, is 4.184 joules per gram degrees Celsius. And then the specific heat of copper is 0.385 joules degrees Celsius. So now that we have all these variables, we're going to plug into the same formula that she uses. So our Q's are equal. So instead of using our Q's, we're going to use our other values. So it's going to be M and then C delta T of water on one side is equal to MC delta T of the penny on the other side. The only difference is one of these is negative to show that, because heat lost is equal to heat gained. And so this should be the same as the video that she used, and then you're just plugging in all these values. And so when I plug in, I'm going to have my 10 for water, my 4.184 for water, and then my initial temperature, so final minus initial, which would be 25. And then on the other side, I'm going to do the same thing, and I'm going to have my 3.14. Oh, I ran out of room. 0.385, and then we're going to do times down here. I'm going to have to make it down below T minus 100. So this should all be on one line, so I apologize. But this is my mass of water times the specific heat of water times my change in temperature. I'm solving for TF, so it's T final minus T initial. Same thing over here. I have my mass of my penny times my specific heat of my penny, which is where I started running out of room. And so then I put a little X for multiply, and then TF minus T initial. And so then all you're doing is solving. So you want to combine like terms. So we want to get the two TFs on the same side. We want to get everything else out. So you need to multiply, you need to distribute, and then you need to move them over in algebra. You can watch her algebra in the video to see how. I'm running out of time because I don't subscribe to YouTube and pay the extra money for the premium. So I only am limited to 10-minute videos. So I can pick back up. If this isn't enough help, I will pick back up with where I left off. I'll wipe off my erase board, and so that way we can have more room. You just need to communicate that with me. So hopefully this is enough to get you started. Let me know if you need more help.